United VU2 United Alpha Victor. Dr. Kavi has done his PhD from Anna University, and he is currently working as a associate professor, assistant professor in the Division of Avionics, Department of Aerospace Engineering, MIT campus, Anna University, for last 7 years. He has completed his research program and master's in Department of Aerospace Engineering, MIT campus. He has been awarded, he has been given an award by Dr.A.P.J. Abdul Kalam, the former President of India. He's also been decorated for excellence in innovation by the Vice Chancellor of Anna University. Dr. Kavi has published more than 17 papers in reputed international journals about the drones and various other subjects. I now hand over the mic to Oldman Kavi, VU2 United Alpha Victor, to give a speech on the drones. Go ahead, Kavi.
Yeah, thank you, Bhagat. Thanks for the nice introduction about myself, and thank you for the Pune Club for the initiative to share my thoughts as well as the views about the unmanned aerial vehicle. So with this thing, I just go to share my slides with you. So if you have any doubts at any time, I requested the members to pause the question. I am ready to share your or clarify your doubts regarding the today presentation. So let us start with the presentation. Just give me a minute. I'm sharing the slides. Yeah. So today we are going to discuss about the the most fascinating topic about the aerospace industry, that is said to be as the drones. So wherever you are going for any sort of applications and all, so you might be heard or you might be fascinated about the word drones. So the drones have that much amount of the potential applications, especially for the civil as well as the military field. So if you look back at 10 years back, what happened, yeah, the name is not that much amount familiar because that time the drones are, the evolving period. So during that time, most of the drones that should be available is in the form of, a research sort of a model. It should be evolved inside the laboratory and whatever the modification or, the development, everything that has been happened inside the laboratory model level. But at a point of time, it has been a branch out from the a laboratory model to the application world. So that's a very important area or the period where the drones has been implemented through the civil as well as the military application. So where it will opening the entire world towards looking towards or opening towards the drone market. So a fascinating thing that should be initially available only for the research laboratory. It has been evolved to the civil as well as the military application. So that's a very important point of the drones. So if you want to understand about the drones, you should be understand about some of the physics or some of the basic that should be associated with the drones. So then only we might have a very good clarity about the drones and how the drones are working and what are all the basic principles that should be associated with the drones. So these are all the understanding is very much mandatory for the users before they have to enter into the drone market. So usually the drones, we can in research aspect we can call it as an unmanned aerial vehicle. So the other name for the unmanned aerial vehicle, we can call it as a drones or unmanned aircraft systems or by several other names. So the ultimate idea of that particular unmanned aerial vehicle or drone is to it has to fly either is in the form of autonomous manner or it flies is in the form of manual or controlling by a human on the loop. So the names are differ based on the application. Say, for example, if it is available in the commercial people, we can claim it as the name as an drones. If it is available is in the form of a civil or military application, oriented application, it is called as an unmanned aerial vehicle, especially if it carries for any uh, attacking operations, we can call it the drones is in the form of unmanned aerial systems. So these are all the the a different normalized category where the drones has been used. So the drones, as I already said, the drones either it can be controlled by means of an a wireless manner or by a program, automatic program we have to fuse it inside the drones. So depends on the applications whether you can control either through by a autonomous manner or manual manner. So that's depends upon your applications. So basically it is utilized in the military application. Now it is extended in application, potential application towards the agriculture, the scientific as well as the commercial applications. Yeah, coming back to the drones, it have various types. So based on the types we can classify the drone. So the first one is said to be as the fixed wing drone or fixed wing unmanned aerial vehicle. The second one is said to be as the rotary wing unmanned aerial vehicle. The third one is said to be as the flapping unmanned aerial vehicle. So further, if you categorize the rotary wing unmanned aerial vehicle, you can classify it into an quadrotor type. You can classify the rotary wing unmanned aerial vehicle is in the form of a tricopter vehicle, or you can classify the drone is in the form of bicopter vehicle. So coming back to the flapping wing unmanned aerial vehicle, it is classified either in the mono-wing model as well as the bi-wing model. So the fixed wing model of an unmanned aerial vehicle, we already aware the fixed wing unmanned aerial vehicle. You can see in the figure what I showed in the slide, the fixed wing unmanned aerial vehicle. The wings are actually fitted on the body of the vehicle. Let us consider this is this particular uh, thing as a body of the vehicle, where you can see at the top of the body there is a wing that is fitted on the vehicle, top of the vehicle. That's what it is called as a fixed wing unmanned aerial vehicle. Whereas in the case of the rotary wing unmanned aerial vehicle, I will show. One second, please give me. Whereas in the case of yes, yeah. Whereas in the case of the rotary wing unmanned aerial vehicle, you can see here in this particular slide, there is a rotor which is fitted on the body of the vehicle, which is necessary for flying, which is necessary needed to lift off the vehicle or needed to fly the vehicle. So the classification is very simple. Whether it is fitted on the body of the vehicle or it is fitted on it's the top of the rotor of the vehicle. So based on the classification, it is classified as fixed wing as well as the rotor. You can see in this figure, it consists of only one rotor. Okay, so this is said to be as a mono wing multi-copter. You can claim it as a mono wing copter or it's a normal helicopter. Whereas here in this slide, you can see that there are two rotating propellers that should be fitted on the vehicle. One is at the top, the other one at the bottom. There are two pair of vehicle. So it consists of two. The two represents it's a bi. So it is said to be as a coaxial or bicopter vehicle. So you might be seeing here also there is an this is also a type of a bicopter vehicle. And the most fascinating thing is whatever you can see in the market is a quadcopter vehicle. It consists of four rotors. Yes, you can see here. This is also a rotary wing unmanned vehicle. You can see here there are four rotors. That is the four rotating propellers that should be available. It is said to be as a quad rotor. Because the rotating body said we can call it as a rotor. So it is said to be as rotor. So if you are having a four, then it is got to be as four rotor. If it is having a three rotating of motors, it is said to be as a tricopter. If it is having only two, it is said to be as bicopter. So it depends upon the number of rotators which is available. We can name it as whether it is a bicopter or a tricopter or quadcopter or hexa essence. It should come to six numbers. So sometimes what happen, if you want to lift off your biggest load, we might go with 8 rotors. It is said to be as octocopter. So depends upon the number of rotors, we can classify the rotor into the number of types of rotors, right? So coming back to the the slide, original slide. Yes. 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 This is a fixed wing unmanned vehicle. This is where we are started. So the next is about the fixed wing unmanned aerial vehicle. Here you can see that at the belly of the aircraft, the wings are fitted. The wings are the wings which is mandatory and it is necessary to fly the unmanned aerial vehicle, right? So how this actually works, that is a very, very important point, and most of you people is already aware about how these airplanes are working. Anyway, for the uh, seek of benefit of all the users, I will explain the little bit about how the things actually works. I will explain. It basically works on the principle of Bernoulli's principle. So you might be heard that the Bernoulli principle, whenever there is a velocity, a low pressure is created on the particular point. So that is the basics of Bernoulli principle. So you might be blown a whistle. When you blow some air on the whistle, at the particular spot, what happened, there is a low pressure, it will be created. So what happened, whenever there is a low pressure, the surrounding high pressures, it will try to move from the high pressure to the low pressure. So this is what a Bernoulli principle. Here also the same principle is applicable. You can see in the figure. So there is the cross section of the wing. If I cut the wing of the unmanned aerial vehicle, it will come to an elliptical shape. This elliptical shape is said to be as aerofoil. So the aerofoil shape is a very, very important one because when it is subjected to an forward air, you can see when there is an unmanned aerial vehicle, if it's trying to move with the help of the motors, what happened, the surrounding environment air, it will be hitted on the wings where the air molecules which hit on the top, it will be traveled very slow manner when compared to the bottom. So the air molecules traveled there, it will be very slow air, whereas the air molecule traveled at the down, it will be move very faster. So whenever there is a higher velocity, what happened, there is a pressure difference, it will be created. So here the velocity is very low, that there might be a low pressure, it will be there will be a air pressure, low air pressure, it will be created here, whereas here the air pressure, it will be high. So as we know the pressure difference, what happened, the air molecules, it always try to move from the higher pressure region to the lower pressure region. So obviously, so here higher pressure, it will be created, where the top of the wing, a low pressure, it will be created. So the air molecules which is presented here, it will tries to pull towards the higher region. Automatically the aircraft, it will be take off from the ground. So this is the basic principle how an aircraft is flying. Right. So right now we know about how the aircraft is flying. In order to produce the lift, that we need some sort of a thrust. So the thrust, which is generally you can get it from the a propeller, a motor which is fitted on the nose of the aircraft. So when the propeller is rotating, what happened, it will push down all the air molecules from the front side towards the backward side. So this is something called as thrust. So when you have a thrust force, what happened, the unmanned aerial vehicle or the drone, it will be moving in the frontward direction. So whenever there is a frontward direction, the air molecules which is surrounded here, it will be hit on the the aerofoil or the wings. So resulting, there might be a differences of pressure differences created. So once the pressure differences created, the wing, it will be produces a force which is called as a lift force. When the lift force is overcome the weight, the airplane, it will be starting or lift off from the ground. So there is something called a drag force. So drag force is nothing but the force which is affecting our thrust force, or it is a force which is opposite to the our thrust force. This is because of the air resistance which will be produced by the body of the aircraft. You can see here the entire airplane. It will be something like elliptical shape. So in order to reduce the particular drag force, they are designing the airplane is in the form of an elliptical shape. It is a best shape in order to reduce the drag force. Our ultimate idea is we have to reduce the drag force and we have to increase the lift force. So these are all the four important forces which are very, very mandatory for flying any drones. So first one is the lift force, the other one is the thrust, the next one is the drag force, and the final one is the weight force. So if there is any imbalance of these two forces, result in there might be a change in the orientation of the particular vehicle. You can see here in the seesaw, right? So if the person, the biggest person, if he apply a small pressure, what happened, this particular part, it will be, the girl, she will be lift off. Similarly, if she apply a little bit of pressure, this person that should be going more. It's like a seesaw. So like we can able to control the plane. If we apply a small pressure at the back side, the front side, it will be moving upwards. Similarly, if we apply a small pressure at the front side, the back side, that should be, we can able to easily control. So this is the same principle how the drones are controlled. You can see here in the figure, if I want to move or lift off my vehicle, so what I need to apply a small amount of force at the back side of the tail. If I apply a force at the back side of the tail, what happened? My airplane, it will be start lift off. The nose, it will be goes upward direction. So a small force at the downward direction, it will create a high force at the upward direction. So how this has been created? This is very interesting. Similar to that of the wings, there is a small amount of a small wing that should be presented on the backside of the aircraft. You can see here, there is a small wing that should be presented on the backside of the aircraft. By means of controlling this one in the upward direction as well as the downward direction, I can able to control the entire vehicle in the upward direction as well as the downward direction. So this is a way to control how an airplane you can able to control. So this is what I said. I said, there is a small a tail fin that should be fitted on the backside of the drone. If I apply a small forces of a small movement at the top side, it's like a seesaw. If I apply a small force here, my aircraft noses, it will be went for takeoff. While for if you go for a nose down or landing, you have to move this one in the opposite direction. You can see here in this animation. Suppose if I want to go for takeoff, the back side there is a small tail will be available. If I move in the upward direction, the nose it will be goes for the upward direction. Similarly, if I go for a downward direction, this it will be go for the downward direction. So moving the airplane, the up and down manner, it is said to be as a pitch axis. So there is a very important axis for airplane. This is said to be as pitch axis. Suppose if I want to roll my aircraft, if I want to turn 180-degree left or 180-degree right, so there is a couple of controlled surfaces which is presented at two ends of the uh, wings. It is said to be as aileron. The particular control name is said to be as aileron. If you can see here, it is very interesting. If one is going upward direction, the other it will be going in the downward direction. It's like a counterclock. It's in a differential manner. So that if one goes up, the other it will goes down. So the airplane it will start moving in the rolling movement. So this is something called as an roll axis. And the last one is said to be as yaw axis. At the back side, you can see here, this is something called the back side. It is a horizontal tile where there is a small control surfaces which is fitted on the unmanned aerial vehicle. By controlling this one left and right direction, I can able to control my drones or fixed wing drones in left direction or right direction. Like our car, if you want to move it in left hand side, it will be moving in the left hand side. If you want to move in right hand side, it will see right hand side. Like I can able to control the drones is in the form of all the three axes. We can generally call it as first one is the pitch axis, the other one is said to be as the roll axis, the third one is said to be as the yaw axis. So any drone, these three axes are very, very mandatory. Either is in the form of fixed wing drone or either is in the form of rotary wing drone or is in the form of a flapping wing drone. Wherever it is, these three control surfaces are very, very mandatory. And it is very, very necessary in order to understand the unmanned aerial vehicle working as well as experts. Right? So I hope there is a small video. You might understand how the entire airplane is working. Maybe it will take a little bit of time. I will explain. Here you can see how the rolling moment occurs, and you can see this is the pitching of the unmanned aerial vehicle. So if he applying the particular control, this is for the left and right, as I explained right now. So it is controlled in the his leg. So while controlling the leg, he can able to control left hand as well as the right direction. So this is how the wire mechanism has been connected. So this is something called a control wheel for an unmanned aerial vehicle. If he move, these are all connected to springs as well as the cables. So which is necessary to control the particular control surfaces. This is something called rudder, like our brakes. If he press like this, it is connected to the corresponding wires as well as levers to control the left and right direction. So this is for the pitch. This is for the left and right direction. So the entire thing is similar as like that, this is for the commercial plane, whereas it is applicable to the unmanned aerial vehicle too. So either it may be a manned mission or unmanned missions. This is very, very important, right? These are all the very basics of the unmanned aerial vehicles before you want to understand how the things are working. So there is a couple of things we need to understand about how how the electronics here it will be helpful for the aerospace engineers. So in the previous video, you might be seen about there is fully mechanical linkages that should helps to control the horizontal stabilizers, the pitch, roll, as well as the yaw angle. If there is any problem in the mechanical linkages, we cannot able to control the unmanned aerial vehicle or the manned vehicle. So with the introduction of the electronics into the aerospace industries, it might be helpful to control these sort of problems. What happened, if you connected these sort of pulley as well as a lever to a commercial airplane, it will leads to lot of cables, wires, everything that should be associated with that one. So result in there is a add up weight because of the mechanical linkages of all the components. It will add over weightages to our aircraft. So if it is an over weightage, what happened? You need lot of amount of lift force is needed. If you want a large amount of lift forces, supposedly you need to spend more amount of fuel in order to fly the unmanned aerial vehicle. So we cannot able to accommodate more number of passengers if the weight is very high. So that's the problem. These sorts of problems has been easily reduced with the help of introduction of electronics. That's the name it is called as avionics. So it will helps to drive our the manned or unmanned aerial vehicle with very minimum weight as well as minimum reduction of fuel in order to accommodate more number of payload into the particular aircraft. And these are all some of the avionics instrument right now. It is available in the commercial as well as the drone market. You can see here, this is something called a display. If you look at any olden days uh, aircraft, there might be a huge number of displays should be there, analog displays. If a pilot he want to fly the unmanned vehicle or a drone or a manned vehicle, he has to frequently look at all the equipments and he has to check out whether the reading is correct or not. Suppose if there is a fire in engine, he has to look down to the particular instrument. He has to first diagnose where the equipment is. So he identify the equipment and he has to diagnose what is the fault. So there might be a plenty of instrument that should be available in the olden days aircraft. It will leads to a tense job for pilot in order to identify the fault. Whereas in the case of right now market, all the displays are come into a single displays like our mobile touch screen. Wherever we want or any emergency warning is need to show it to the pilot immediately. That should be displayed on the the pilot main display. So that it will help to reduce the number of equipments as well as it will accommodate the pilot space. So that's the biggest advantages of using this the display system. Whereas this is for the communication equipment. If you look at the communication equipment, the aircraft similar to that of our HF, VHF, satellite. So there are plenty of communication equipment will be available. The some of the additional equipments are the aircraft directional finder. So there is a ground-based transmitter that should be available at every airport or throughout the path of the airport. It will produces a non-directional beacons to us. So the pilot they have to tune towards the particular beacon frequency to identify the location of the particular spot. So this is something called ADF, the aircraft directional for automatic directional finding equipment. And there is something called to land our aerial vehicle. There is something called ILS, Instrument Landing System. So it will help to safely land our vehicle without affecting any external load to the pilot. There is something called microwave landing system. So these are all the some of the equipment that should become comes under the communication category, where some of the frequency we are supposed to here while tuning our radio too. So these are all the some of the equipment, and you can see here there are plenty of sensors are available. There is something called the air data system sensor, inertial sensor. So these inertial sensor is a very important sensor. So with this help with the help of the sensors only we can able to fly our quadcopter sort of drones. And there are additional equipments are there, something called a radio navigation system, dead reckoning navigation system, and these are some of the payload like infrared sensors, radars, housekeeping management. So these are all the associated electronics. It will help the pilot or the drone operator to optimize the work. Right? So these are all the some of the important factors. And this is about how the helicopters are flying. You might be seeing about how the helicopters should fly. It's a comparison between the helicopter as well as the a fixed wing unmanned vehicle. Here it has a wings, whereas this fellows it has a rotating rotor. You can see here fixed wing. This is the rotary. And this is for controlling the speed of rotating of the rotor. It's something called a collective. If he increases, the speed it will increases, result in the lift force it will increases, it will be take off from the ground. And that's very interesting video. It shows the comparison between the fixed wing unmanned vehicle as well as the rotary wing unmanned aerial vehicle. So here the very important factor of the unmanned aerial vehicle, the rotary wing unmanned aerial vehicle is you already seen about there is a rotor which is rotating on the top of the helicopter. So what happened, when it is at the ground place where the rotator is rotating, it's not at all a problem. Once it start lift off from the ground, what happened? There is no friction between your helicopter as well as the ground. Now it is in the air. So your entire helicopter body, it will start rotating towards the direction of rotating of the rotor. So the body itself, it will start rotating. So if it is rotating, this is something called auto rotation. If it is rotating along with the rotor, we cannot able to fly the helicopter. It is common for all the drones, especially for the rotary wing drones. So we need to compensate it. So in order to compensate it, we need to measure how much amount of rotation the helicopter is currently experienced. So with the help of this calculating the rotation, we have to give a counteract force. So the counteract force, it's nothing but a motor which is fitted on the tail of the aircraft. So if you look at any helicopter, the backside there is a small rotating propeller that should be available. So it will not keep on rotating. Sometimes only it will rotating. It will helps to find out how much amount of the auto rotation force is created by the body. Suppose if the helicopter start rotating towards the direction, the propeller at the helicopter back tail, it will start to rotate in opposite direction so that it will restore the original rotation of the helicopter in air to the normal. So this is something called tail compensation rotation for the helicopter, right? So here it is the important questions it will be raised. How we have to calculate the auto rotation of the helicopter angle. So that's very important. So in order to calculate the auto rotation force, we are supposed to calculate what about the pitch axis rotation, what about the roll axis rotation, as well as what about the yaw axis rotation that we have to find out. So with the help of, there is something called gyroscopes and accelerometer, we can generally called as IMU, inertial measurement unit. So the inertial measurement unit is a device. It will helps to find out the angle of the helicopters. What about the pitch angle? What about the roll angle? What about the yaw angle? So these information we can easily able to get from the inertial measurement. Say for example, if my helicopter it is moving in this direction, so the IME which is fitted on the helicopter, it will senses your helicopter is rotating in this particular angle. It will senses the reading and it will gives the correction signal to the tail rotor of your helicopter. So if it is rotating in the clockwise direction, it will instruct the tail rotor to move in the opposite direction so that your helicopter, it will be come back to its original position. So this is the role of the inertial sensors in your aircraft. It is common for all the three axes. If it is having a pitch up or pitch down or rolling, it depends upon the classification of the unmanned aerial vehicle. It will compensate the counteract rotation of the particular aircraft. So why it is actually needed? So it will give you a reference of reference to the pilot or the flight controller where it is from. Say for example, I'm sitting on my the work table. Suppose if someone want to know my position with respect to the corner of the building, I can able to define my position. From X distance I am sitting. From Y distance from the corner I am locating so and so distance. From Z reference I have to set this much amount of height. I can able to define my position of the particular place. Whereas in the space, if you look at space, there is no such reference should be available. The space is open to you. We cannot able to define a reference of the space. So in order to define the reference, we are supposed to use a angle name as pitch, roll as well as yaw angle. This we already discussed, right? So this is something called a reference angle for the drones in order to identify where you are and where you should be and how your force should be. So this is something called the pitch roll as well as the yaw axis. So how they have to easily identify the particular axis, that is very important, and it's a little bit of mathematics sort of things. I will try to explain with the help of IMU. We can the IMU comprises of two main equipment. The one is said to be as the accelerometer, the other is said to be as a gyroscope. I'm not going in depth about how the working principle and all. Anyway, I will try to cover. With the help of the gyroscope, we can able to identify the three angle: pitch angle, roll angle, as well as yaw angle of the vehicle. We can able to find out the angle with the help of gyroscope. Similarly, we can able to identify the angle with the help of accelerometer. So now I have two sensors. with this help of sensors, I can get very good characteristics from one sensors. Similarly, I have some bad characteristics too. Similarly, the sensor too, I have some good characteristics as well as some bad characteristics. So what my ultimate idea is, I always focus on good sort of reading. So I'm going to fuse the data which is coming from the sensor one as well as the data which is coming from the sensor two. I'm just going to fuse these two data together in order to provide the better result. This is something called sensor fusion. So the sensor fusion, okay, right. Yes. The sensor fusion, it's a technique. It will helps to get the good readings from one particular sensor as well as very good readings from the other sensor. So how we have to achieve it? The sensor fusion here, it's a technique. It will helps to combine the data from two different sources. So the first method is something called a complementary filter. The second method is something called a Kalman filter. The third method is something called extended Kalman filter. The fourth method is something called uncentered Kalman filter. The fifth method is something called particle filter. So these are all the some of the data fusion technique. Right now it's available to all the scientific people. Just for simplicity, I just going to explain the complementary filters for you. Say for example, you can see here in this equation, the theta of estimate. The theta of estimate is equal to the angle which is coming from the final. So this is my interest. Say for example, I have two sensors. The one sensor is the theta from the gyroscope. The other one is the theta from the accelerometer. I have to write it in such a formula, in a such a way, in the first equation alone. You just concentrate. I have to write it such a way. If I put L is equal to 0, what happened? What happened? The entire term, this term, everything that's cancelled. So the final output of my uh, algorithm is only the data which is coming from the gyroscope, right? Suppose if I put L is equal to 1, what happened? If I put L is equal to 1, this terminology, theta of gyro as well as minus theta of gyro cancelled out. Now I will get the angle of only theta of acceleration. So theta of the sensors, the second sensor. So depends upon the L value, I can able to choose whether it is from the sensor 1 or it is from the sensor 2. So that's my ultimate idea. But here the important point is how you are going to fuse these two data. Let us say instead of putting 0 or 1, now I am going to give you a value of L is equal to 0.5. If I give you a L is equal to 0.5 value, so I'm going to give you a weightage of 0.5 weightage to the first sensor as well as 0.5 weightage to the second sensor. Let us assume such a case. I have two different antennas for my radio. One is from the theta gyro, the other is from theta accelerometer or theta x. I have antenna 1, antenna 2. So if I put L is equal to 0, the entire term it will be 0. L into anything is 0. L into 0 is 0. So 0 into anything is 0. I will get the data from this antenna 1. If I put L is equal to 1, what happened? This positive term, this negative term cancel, I will get the data from the sensor or antenna 2. So if I give a weightage of 0.5, I will get a very good data from the antenna 1 as well as I will get a data from the antenna 2. So that's the fusion technique of using the weight. Similarly, if I put a weightage of 0.25, I am just going to give a higher weightage to one antenna and lower weightage to the other antenna. That's a very simple technique. By using a simple mathematics, we can able to fuse the two different algorithms or two data into a even better output. So this is what I explained here. L is equal to 0 means the gyro-based angle. L is equal to 1 means accelerometer. It's a way of getting the better results for your applications. Right. So now you can understand. Here I can able to calculate the altitude of my drone. I have two sensors. The first sensor is something called BMP085. The other sensor is something called BMP180. If I put L is equal to 0, I can get the data from this barometer 2, this alone. If I put L is equal to 1 means the barometer 2 cancel. The barometer 1 data only I will get. That's a very simple. Coming back to the rotary wing, we already discussed about the helicopters. It's a type of a rotor which lift is produced by the rotor of the vehicle. So this is what I already explained. This is the tail rotor. You can see here, might be, yeah. This is the main rotor. It is at the air. So let us assume it is rotating in the clockwise direction. So once it is in the air, the body, the entire body, it will be start rotating towards the clockwise direction. In order to compensate this one, we are supposed to fit a gyroscope on the front of the uh, or the center of gravity of the helicopter. It will senses the auto rotation. Depends upon the rotation, it will drive the tail rotor. The backside, you can see here, there is a rotating rotor will be there. So depends on the speed of rotation, it will tries to rotate faster so that it will produce or it will create a counteract force in order to arrest the auto rotation of the unmanned aerial vehicle so that it will be flying in the same direction. So this is something called, instead of a single rotor, it consists of two rotors. It is said to be as a bicopter. So this is also a biaxial type. It is mainly used for a defense application. So why they are using the bicopter is, let us assume if you have one rotor, it will carry a lift of about 100 kg or 200 kg. If I go for an additional of another rotor, what happen? It will carry the double the times of the weight. So especially it is used for the cargoes of military. If you want to deploy a large number of your armed forces towards the border or carry huge number of payload, we can easily adapt it here. So that is what they have to go for the dual thing. Okay, dual rotator. Similarly for military aircraft, it will helps to carry more number of armaments or bombs or to deploy to our friendly nations. So that's what they are usually using. This is also another top of bicopter. The previous thing you can see that at a single point the two rotors are there, whereas in this case there should be two rotators that it is separated by a distance of L. So now it will carry more number of payload when compared to the previous one. It helps to carry more number of payload to deploy. You can see inside the belly of the aircraft. You can see more number of tankers or vehicles or passengers. Most number we can able to easily deploy it here. So that's the advantage of using the bicopter. Okay, coming back to our today fascinating thing. This is something called a quadcopter. So here the interesting facts comes. You can see here the most important thing is it consists of four rotors. It consists of four rotors. Let us assume it's a DC brushless motor. If I give you a voltage to each motors through a driving equipment, we can generally call it as a electronic speed controller. If you give a pulse to the particular driver, it will control the current. So the current indirectly it will control the speed of the rotor. So right now let assume that if I give you a voltage, the speed gets varied. So just assume us like that. Okay. Okay. So now you can see here it consists of four rotors. It consists of four rotors. All the motors are connected to a common power supply. If I give a voltage to the motors of about some 2 volts to all the motors, the motor it will start rotating. The motor it will obviously start rotating, but the speed of the motor is not ideal to one another because of the manufacturing defect of the motor or manufacturing capacity of the motor. What happened, if I give you a 2 volt, this one motor it will be driving at a speed of 100 rpm, revolution per minute. Whereas the same 2 volt, this particular motor it will be rotating at a speed of 1300 rpm. Whereas this motor it will be rotating at a speed of 1150 rpm. Whereas the last motor it will be runs at a speed of 1500 rpm. So same voltage, the motors depends on the characteristics, the speed might be varied. So if I give you a voltage, if I want to take off the particular quadcopter to lift off from the ground, if I give you a voltage, because of the differences of the speed of each motor, whether it will start lift off or not, if you ask the question, definitely it will not take off from the ground because one motor, it will be rotate very fast. It will produces very high lift forces on the particular motor when compared to others. So this is not ideal to each other. That's because of the natural characteristics of the motor. Nothing of no motor is a perfect one. It consists of its own laws. It consists of its own electrical or mechanical laws. It's also the characteristics of the motor. So we cannot simply give you voltage to each and every motor and expected the quadcopter it has been lifted off from the ground. So it's not at all possible. Here, where the important concept it should becomes here. There is something. Sorry, madam.
Yeah. Kavi, it's over 45 minutes. So, with more slides,
Sorry, sir, your signal getting choppy.
yeah, Kavi, how many more slides are there? No? We have crossed 40 minutes.
Oh, okay. So how long? Shall I take 5 more minutes?
Yeah, you can continue.
Yeah, just five more minutes. Okay, I will wind up quickly. Fine. So this is something called the quadcopters. So if I want to control it, where our important things come here, we already described about the IMU, inertial measurement unit. Let us consider because of the rotation of one motor, uh, it, it's subjected to some rotation, right? It's subjected to some rotation. Now, if you place the inertial measurement unit on the equipment, it will senses how much angle it is tilted. So immediately it will instruct the controller this much amount of angle is experienced from so and so axis, and will inform the counteract motor here just to increase your speed by this much amount. So it will senses how much angle it is tilted, and it will drive the counteract motor so that the unmanned aerial vehicle, now the tilted unmanned aerial vehicle, it will try to come back to its a normal position. Similarly for this motor, so this sensor is deployed for all the three axes so that the inertial measurement unit, it will senses the particular variation of the angle, and it will instruct the motor to come back to its original position. This is the way how the unmanned aerial vehicle is stabilized, especially for the
Time is up, sir.
Yes. Yeah. Sorry.
I said your time is about to end.
Yeah. Sure. I will wind up. No problem. Yeah. Shall I continue or I have to wind up? Sorry.
Vilas, he has got only 5 more.
Please continue. Please continue and
Okay. I will take
Continue.
5 more minutes. Yeah. Fine. You can see here because of the pressure difference. You can see in this thing. Suppose if I want to go upward, this particular figure, you can see all the four motors are running at the same speed. It has been easily achieved with the help of the inertial measurement unit. Suppose if I want to move rightward direction, you can see here this particular one motor, the speed I have to increase, whereas the opposite motor I need to decrease the speed, so that this one speed get increases, the other speed get decreases, resulting there is a small differences of the angle. So the unmanned aerial vehicle, it will start tilting and move towards your right hand side. Similarly, this particular angle, if you want to increase front direction or back direction or left or right, based on the speed of a slight reduction of the speed, we can able to easily achieve with the unmanned aerial vehicle. So as I already said, I have gyroscope, I have accelerometer, I am using a fusing algorithm in order to identify it, and what about the thrust needed, where I want to go, that is left direction or right direction. So depends on that, I have to mix the signal and I have to drive all the motors. It will help to generate my force F1, F2, F3 as well as the F. And this is about the quadcopter, how it is flying. And this is the most interesting thing. This is something called ornithopter. So you can see here, it will fly like a bird. So it's something called a mono-wing ornithopter or a bi-wing ornithopter. So it can fly like a bird. So it's somewhat interesting if you see this video. I think it's not. Okay, fine. So it's flapping its wings like a bird, and it will helps to easily escape from enemy radar, or it will helps to easily escape from where the human cannot able to see. And these are all some of the mechanism for the unmanned aerial vehicle. So this is something called a hand launching mechanism. With the help of your hand, we have to initially launch the unmanned aerial vehicle. And this is something called pneumatic mechanism to launch the unmanned aerial vehicle. This is with the help of the spring technique, we have to launch the unmanned aerial vehicle, and this is something called a jettison. So it will help to release the unmanned aerial vehicle. Yes, and this is the autopilot. You can use any autopilot. It will use the same inertial measurement unit as well as the driving equipment to control your unmanned aerial vehicle. These are all the some of the famous autopilots: Autopilot, Pixar, and these are all the things available commercially. DJI and also, I suppose any newcomers, if they want to fly your unmanned aerial vehicle, I recommended you to use the DJI NASA. It is a very perfect autopilot. It will help to fly. Anyone can fly with the help of the DJI NASA. And there is something called Glue-On. It is a real-time operating pilot. And this is a multi-V. It is a very cheap level flight controller, but it is a very beautiful flight controller. And these are all some of the KK multi-copter board. It is a very basic flight controller. Anyone, they can easily get this flight controller, and they can fly for the drones. So these are all some of the sensor. With this, I will like to wind up my session because I'm exceeding my time. I know. Fine. So up to this, if you have any doubt, kindly let me know. I'll try to explain best of my knowledge. So over to you. If you have any doubts.
What any queries if you have? Please first identify yourself and then ask the question. No queries.
Yeah, fine.
So I will request you to MSB to propose vote of thanks and close the session.
Roger that, Vilas. Yeah, this was a very good presentation, Old Man Kavi, Dr. Kavi. This is a very good presentation, and I would like to have one more session again for the interested people. Yeah, though today's turnout was not so good, but the presentation was excellent. And yeah, I think we will be able to bring in more people, more students, particularly from the universities here, which are interested, and people, students who are working on the UAVs or the drones, they'll be certainly interested in joining up. Though this time they could not join because today there is an exam going on here. The students in the ham community, they have mentioned that there is an exam going on today, and so they are not able to join. So we'll have one more session, and I would like to have a good session from you in the next time. Thank you, Kavi. Thank you, all the participants. And we now declare this session is over. Bye-bye, everybody.
Yeah, thank you, Vilas sir, as well as the Bhagwat sir. Thank you for the opportunity for sharing my insights towards your team. Thank you once